Alright, today we're going to talk about sector area. And what sector area is, it's part of the area of a circle, so a sector of it. And we're going to kind of use what we talked about yesterday, where we're going to take a fraction of the area. So if we go down and look at the formula, we have the sector area, and this part right here, this is the area of a circle. And just like what we talked about with arc length, we're going to take our area and multiply it by the fraction of the circle we want. So if we know that our central angle is 50 degrees, well, we're going to do 50 degrees divided by 360 to get what fraction we want. So that's why you have this right here. This tells us the fraction of the circle that we want. So x is still the central angle of the arc. So I'm going to do example A, and then I'm going to have you try example B. So the sector area is x over 360 times pi r squared. So if we just substitute what we know, area equals 63 over 360 times pi r squared. And just like what we talked about yesterday, well, we know what r is. R is 5. We're going to type all that into the calculator. So 63 divided by, parentheses, 63 divided by 360 times pi times 5 squared. And that gives us 13.74. So the area equals 13.74. Okay, so I want you to pause the video and try example B, and then after you're done, unpause it and see if we got the same answer. Okay, so I hope that you got the answer of 74.93. Again, if you rounded differently, then your answer might be a little bit off, but I don't suggest it. I suggest just typing this whole thing into the calculator and then rounding to 2 decimal places. Alright, let's look at the next page. So here we're given the area of the sector. So we're given that this area is 36.07, and we want to find the area of the whole circle. And just kind of like what we did yesterday, we're going to plug that in to the formula. So area equals x over 360 times pi r squared. And we don't need to get the radius by itself. We just need to get this part by itself because that's the area. Now, we know the x value is 58, and we know what our a value is. It's 36.07. So then when I set this up, it's going to be 36.07 equals 58 over 360 times pi r squared. I'm going to divide 58 by 360, and we get 0.16. So 36.07 equals 0.16 times pi r squared. And then we can divide both sides by 0.16. So 36.07 divided by 0.16, that gives me 225.44. So 225.44 0.94 centimeters squared. That is equal to pi r squared. And that's our area. That's what we're trying to find. So again, we didn't need to figure out what the radius was. We were just able to get the pi r squared part all by itself. All right, for letter B, we're going to have to do some more math than we did before because we were asked to find the diameter. In part A, we were asked to just find the area. That's why we were able to leave this part alone. But in B, we're going to have to get r by itself because we're asked to then find the diameter. So it'll be a little bit more math, but it'll be fine, and it'll just be a little bit more work. Okay, so the area of our sector is 72.39. Now, the angle over here is 109, which means this angle of the shaded region must be 360 minus 109, and that equals 251 degrees. So this must be 251 degrees. So then my arc length, sorry, not arc length, my sector area, 72.39, is equal to 251 over 360 times pi r squared. Now, I'm going to, like I did in the previous problem, I'm going to simplify this fraction, or make that a decimal, and I get 0.7 when you round it 2 decimal places. So 72.39 equals 0.7 times pi r squared. Now I'm going to divide both sides by 0.7 pi. And I know that's different than what we did in the other problem, but again, in the other problem, we were asked to find just the area. And I wanted to make sure that my final answer had pi r squared in it. Here, I want to get r by itself, so I need to divide both sides by 0.7 and pi. So then, remember in the calculator, I'm going to show you, you want to do 72.39 divided by parentheses 0.7 pi. Okay, so then we get 32.92. 32.92 is equal to r squared. And then we square root both sides. So the square root of 32.92 is 5.74. So 5.74 is equal to r. Well, remember, the diameter is 2 times the radius. So we have to multiply that by 2, and we get 11.48. So 11.48 feet is equal to the diameter. So we had to go a little bit further in this one. All right, let's look at example 3. So example 3 will kind of combine stuff that we did yesterday with stuff today. So it says the area of a circle is 295.52 square inches, so that's the area of this whole circle, and that the area of the sector is 55 square inches. So the first thing they're asking us to find is the radius. Now, I think the easiest way to find the radius, if we're given the area, is to use a formula, area equals pi r squared. We know the area is 295. So we can plug that in, 295.52. We can plug that in for the area, and then we can get r by itself. So let's do that first. So 295.52 equals pi times the radius squared. well, remember we divide both sides by pi, and then that will give us 94.07. So we get 94.07 equals r squared. And then when we square root both sides, r will equal 9.7. So 9.7 equals r. Now that we have that as our radius, finding the circumference should be no problem at all. Circumference equals 2 pi times r. So the circumference is 2 times pi times 9.7 from the part that we did in A. Over here in A we got that the radius was 9.7. So we type that into the calculator and our circumference is 60.95 inches. Okay, so now with A and B done, we can look at C and D. The part for C is asking what is the arc measure for PQ. So they're not asking about this arc length, they're talking about the angle measure. So we want to figure out what this angle is right here. And we know this area is 55 square inches. So we can use the sector area formula. Area equals x over 360 times pi r squared in order to find x, because we know that the area of the sector is 55. So let's plug that in. 55 equals x over 360 times, we know that the area of the whole circle is 295.52. So 295.52. Okay, so now what I'm going to do is write this over 1, because what I'm going to do next is divide these two to get a decimal. So if we do 295.52 divided by 360, we get 0.82. So 55 equals 0.82x. Divide 55 by 0.82, and we get 67.07 equals x. So the arc measure is 67.07 degrees. Now we can take that angle measure, that arc measure, and find the length of arc PQ. So now we're trying to find the actual distance from P to Q. And the arc length formula, x over 360 times 2 pi r. Now you could take this circumference and replace it with what we calculated up here, or you can just recalculate it again. It doesn't matter. So the length will be our angle measure we found in part C. It was 67.07 over 360 times the circumference, 60.95. And again, you could leave it like that, or you could write 2 pi times 9.7. You'll get the same answer. So I type that into the calculator, and I get 11.34 inches. So again, if yours is a little off, that's fine. You just round it differently. It's okay. Don't worry about it. As long as you have the correct work shown, and your number is only a little bit off, I'm okay. It's fine. Alright, let's look at the last example on the last page. So you may have heard of the saying that you can't fit a square peg in a round hole. You actually can, but if the square is small enough. So we're going to pretend that we have a round hole that's 4 inches in diameter. So I'm going to draw that. Diameter is 4. And in order to fit a square peg into that, okay, so the square peg here, that means that the largest distance should be the diagonal, which should also be 4. So I'm going to erase this and write 4. Well, you may remember from our special right triangles that a square, if you cut a square in half on the diagonals, we then have a 45, 45, 90 triangle. Well, in a 45, 45, 90 triangle, the hypotenuse is 2 times the square root the size of the leg. So basically, if I take my hypotenuse and divide it by the square root of 2, that will give me the leg. But we can't leave a square root in the denominator, so then we get 4 times the square root of 2 over 2, because remember these two multiply and give us 2. And then we can simplify this. 4 divided by 2 is 2 square root of 2. So that is the exact length, 2 times square root of 2. But what this problem is asking for in letter A is what is the approximate. So you want to type that into the calculator. 2 times the square root of 2 is equal to approximately 2.83. So you could have used special right triangles for that one. You could have also used Pythagorean theorem. These two sides are the same. You could have done x squared plus x squared equals 4 squared is 16. X squared plus x squared is 2x squared equals 16. And you could divide both sides by 2 and then square root and solve it that way. It's just, in my opinion, easier to use special right triangles when you can. So this is an interesting application of this problem of using special right triangles and applying that to circles as well. But if this doesn't make sense, don't fret too much about it. Pause it, rewatch it again, and hopefully it becomes more clear, or you can just ask me next time I see you guys. So I will catch you later.